In a previous video, we visited a ridgetop position, saw chestnut oaks up there, we were down at the bottom of the slope in the valley, we saw sycamores. Here we're kind of in a mid-slope position, and two of the common species that you see behind me are white oak, kind of rounded lobes, and sugar maple, we see on the Canadian flag. The white oaks are the big trees behind me, right? With this pale bark, right? So they stand out here. And yet all the smaller trees, about this big and smaller, tend to be sugar maple. So this forest that I'm standing in is pretty old by Ohio standards. It's probably 150 years old or so. And that means that the oaks have been here for a good long time. They established in the 1800s. And the maples, the sugar maples, probably established in the 20th century, mid-20th century or later. So why the change, right? So if we think about what happens when this white oak falls over, right? It's the older tree. What's going to likely replace it? It's probably not another white oak. It's probably going to be one of these smaller maples, kind of waiting there for the opportunity to ascend into the canopy. So we're kind of in a period of transition. So why are we seeing this difference? Why do we see oaks in the overstory and maples in the understory? Some people would argue that it's fire, that the Native Americans used to burn frequently, and the oaks are able to handle fire more so than the thin bark maple. It could also be a climate change. So the 20th century, when these maples established, was the wettest century in the past 5 centuries, right? So it really was a wet climate that favors maples over oaks. When the oaks established, it was a drier climate. So a couple different reasons to explain this change in pattern that we're seeing, change over time, and it very well might be several factors operating in concert. Speaking of tree fall, we've got one behind us, right? So let's go take a look at that. So I am in the pit caused by this tree that went down. This is the tip-up mound, right? So a bunch of soil went with the root mass. Kind of makes for micro topography, right? So we have a different environment here. We've churned the soil up. I'm in a pit. There's actually a different microclimate here, and some plants tend to colonize these tip-up mounds compared to the pit. So it's kind of neat, this topography acting on a really fine scale. Like I said, this forest is getting pretty old. Your forest, if it's not that old, you might not see tree falls like that. Even here I can see some stumps around, right? So again, there's that past land use imprint still here. But this is a neat forest in that we are starting to get some downed trees. And that's really important from an ecosystem perspective. As the trees go down, they add nutrients. The decomposers kind of work on those. They can retain water to help moisture relationships. They're cycling nutrients, as I mentioned. So they're really important habitat as well as providing nutrients to the ecosystem. The other thing to note here is the gap that this tree created when it went down. You can see that opening, and it changes again the resources for the other plants here. So the smaller trees shoot up into that, right? So this kind of episodic growth spurt, and the larger trees kind of fill it in. So this tree went down 10 years or so ago, and so some of that filling has already occurred, but we still see that gap. So that's really important for forest dynamics, in thinking about how it changes over time. Here's another tree that has gone down. This one actually snapped off higher up there. It's on a ridge position, and so there tends to be stronger winds on the ridges, so it makes sense that this guy was more susceptible. It also seems like it was struck by lightning, this blackening, kind of a fissure. So you might see that walking around the woods. If you see like a long split in your tree, especially if it's got this blackness on it, it's a lightning strike. So this tree was probably already weakened by the lightning strike, and then the strong wind kind of snapped it off maybe 15 or 20 years ago. It's been a pretty long time, as you can tell by the state of the bark. But it created a gap, just like the one we saw previously. But this one's been here long enough that it's actually filled in. So we see some smaller trees took advantage of that opening and shot up into it, right? Kind of episodic growth spurt going on. But some of the other trees just kind of infill, right? And you can kind of see their branches closing in on this area. So the tree goes down, it creates a gap, opens up resources for the other plants to take advantage of. And that's what happened here.